This chapter is ongoing on your school, or has it been completed?
Sir, it has been completed, sir.
It has been completed. Okay, okay, good. All right. So you see, so far now we basically talked about heat, and I'm trying to quickly give a glimpse of what we have discussed so far in the class. All right, Mufaz. So number one question comes to our mind, that what is the ultimate source of heat and light on Earth?
Sir, sun.
What? That is sun, right? So sun emits sun emits heat and light. Okay, that is the source of life on Earth as well. Okay, sun is the ultimate source of light and heat on Earth, right? And yes, so one basic question regarding to heat is that you see all the particles which you see around, all the substances which you see around yourselves, they are made up of very tiny particles. What do we call that particle? We call them as molecules. Okay, and these molecules are continuously moving. Okay, whether the substance is solid, liquid, or gaseous in nature. All right, Mafaz. So the molecules of the substances are continuously moving. Okay, so they are having some sort of energy. Okay, why are they moving? Because they possess some amount of energy, right? So basically the sum of all the energy possessed by these moving molecules of the substance is called thermal energy, right, Mufaz? You there?
Yes, sir.
Okay, so you take example of any substance. Let's say this is a rod here. Okay, this is an iron rod. Okay, and it is warm. Okay, if you touch it, if you feel that it is warm, the reason is why, because the molecules of this rod are in continuous motion. They are continuously moving. They are continuously moving. They are continuously moving. Why? Because they possess a type of energy, and that type of energy is called thermal energy. Okay, so thermal means heat here. Okay, therm means what? It means heat. Okay, so the heat the heat which we experience for any given object, this heat is coming from the movement of the molecules. Okay, and how do we define heat? That when a hot object and a cold object comes in contact with each other, a type of energy flows from hotter object to the colder object. So that type of energy which has flown here, that is simply called as heat. Okay, and what is the SI unit of heat?
Mm. So
That
molecules.
no, SI unit. Look, SI unit. Okay, SI means system international. That is the international system. It stands for international system. Okay, like you see, if I give you give you some amount of milk, how do you measure that milk? If I'm giving you some amount of milk, you measure it in liter. Okay, you will not measure the milk in milk in kg. Okay, or if I give you, let's say, a length. Okay, if I am giving you length, you will either measure it in meter or in kilometer, right, Mufaz?
Yes,
So
sir.
every quantity is measured in a system. Okay, so that system is called international system. Okay, so every substance which we are able to measure, or any given unit which we can measure, whether it is distance, whether it is mass of substance, whether it is a liquid, we measure it in international system of unit. Okay, so for heat, if you are if you ask to measure heat, you will measure it in joule here. Okay, it is joule. So the SI unit of heat is joule. All right, so if question is asked that how much of energy is being emitted by a body, you will say that 100 joule of energy or 150 or 200 or 1000, any given amount, whichever is being emitted by the body, you will represent it in terms of joule. Right, Mufaz? Okay. We won't say the object is slightly warmer or it is too hot or too cold. We represent it in terms of joule. All right, got this. Shall we move ahead then?
Yes, sir.
Yeah. Okay. Now remember earlier we did this activity to basically conclude that hotness and coldness are relative terms.
Okay. Yes, sir.
Yeah, we did this. In fact, we did this activity where we took three balls. In one of the ball we took warm water, another cold water. In the third ball we took lukewarm water. Okay. So in this, basically we concluded that hot and cold are relative terms. Okay. And we concluded that heat flows from a hot body to a cold body. Okay. That is the reason why our warm hand was in our hand, the hand which we kept in the warm water. When we place the same hand in lukewarm water, we experience coldness in that hand. Okay. That was the reason. Okay. Now, few questions here. Which sense in your body helps you in learning about cold, warm, and hot? And hot.
It's touch.
Touch. Very good. See, next question. What is heat?
Mm,
It is the energy that flows from a hotter body to a colder body. Right. So we say
yes.
that heat is a form of energy. Right. That flows from where to where?
Because hotter part to the colder part.
Exactly. Hotter to colder body or parts of the same body. Okay. At what time of the day and place you feel hot?
Sun. Daytime.
During daytime, when it's 12 o'clock around, right? When the
Yes.
sun is overhead. Okay. You have a, see, question number 4. You have a chilled bottle of cold drink and a glass of boiling tea. Which of the two has more of heat energy in it?
So the glass of boiling tea.
The glass of boiling tea. Why is it so?
So because it is heat energy.
It has having heat energy. Okay. But to be specific, Namafaz, you will see here, let's say you are having glass of boiling tea here. Okay. So if you remember in the beginning of the class, I told you that everything is made up of extremely small particles. Okay. And these particles are called molecules which show movement. That is, they are not continuously moving. Okay. So if you heat the substance, the speed of their motion will also increase. That means they will have more energy. So if you have a glass of boiling tea here, boiling tea here, you see the molecules of the tea are in much more motion. They are having more amount of energy here because they are moving faster as compared to the molecules of cold drink. Okay, that is the reason. Got it?
Yes, sir.
Okay, so how do you define this?
So because the heat the heat gets the heat moves very fast.
No, because it is, since it is a boiling water, the molecules are showing more motion. Okay, the molecules are rapidly showing rapid movement. That's why it has got more energy. Okay, hence it will have more heat energy in it. Okay, so you see, after a point, let's say if you boil water now, after a point of time that you will see it starts to boil once it reaches the boiling point. So don't you see there are waves produced in the water. When the water starts to boil, it produces bubbles and the water starts moving. Okay, it is because the particles have got so much of energy from the heat that they are showing so much of movement, right? If- so see a calm water, a cold water, or a boiling water. Okay, name some different forms of heat energy. What are some different forms of heat energy? Yes, my fast.
The conduction.
No, that is not forms of heat energy. Those are different things. Name some forms of heat energy. Yes, what are different forms of heat energy?
So cold and hot.
No, that is another thing. No, forms of heat energy. One is, you see, it is heat coming from sun, right? That is a form of heat energy. What else? Heat coming from burning of fossils and fuels. Okay. Heat coming from volcanic eruptions, right?
Yes, sir.
Okay. Okay, now move on. Now we also talked about temperature, which is basically what? How do you define temperature?
So the heat with the heat. Uh,
No, read the given definition here.
the degree of hotness or coldness of an object is called temperature.
Right. The degree of hotness and coolness of a body is called temperature. And its SI unit is what? It's Kelvin. In short, written as capital K. All it move fast. Okay. And we have got instrument for measuring the temperature that is called thermometer. And thermometers are also of three types. One is the clinical thermometer, second one is the digital, and the third one is, which one is used in laboratory thermometer. Now, out of these, which thermometer has largest range?
The laboratory laboratory thermometer.
Laboratory thermometer, right? Okay. And you tell me, why is it better to use a digital thermometer in place of clinical thermometer for measuring body temperature?
So because the clinical thermometer can break.
It can break, right? And also, if mercury, when it will break, when mercury is exposed to children's, it is very toxic. So mercury is toxic, it is expensive also. So if someone consumes that mercury by accident, or some children, if the children consumes it by accident, it can be very toxic for their health. Okay. And whereas digital thermometer does not work on the expansion of mercury principle. Okay. In clinical thermometer, we see that it basically works on the principle that when mercury is heated, it expands. Okay, and due to the expansion of mercury, we get the reading. Okay. Now, what are some of the precautions we need to take while using a clinical thermometer?
Okay. So we should handle it carefully.
Yes, we need to handle it properly, and
We should not hold the bulb of the clinical thermometer.
that will come under handling properly. That will come under handling it properly. Next thing, we need to ensure that the while you're taking the temperature of the patient, we need to ensure that the temperature before measurement is not above 35 degrees Celsius, right? So you need to give it a slight jerk like this so that the mercury comes back to a reading below 35 degree. Right, Mufas?
Yes.
Okay. While these limitations are not in digital thermometer, you can just reset the temperature back to 35 or back to 0 degree. Okay. And what is the range of laboratory thermometer?
Minus 10 degree to 110 degree.
Exactly. Minus 10 degree Celsius to 110 degrees Celsius. Very good. Okay. Now, temperature scales. You see, there are different scales of measuring the temperature, right? So most common of the temperature scales used are what? They are Celsius scale, Fahrenheit scale, and the Kelvin scale. Remember, Celsius scale, Fahrenheit scale, and the Kelvin scale. Okay. So you see here on a thermometer, 0 degrees Celsius is the melting point of ice. You know already this thing, and is called the lowest standard point. Remember this point. This is important here, that the lowest point in a thermometer, that is the melting point of ice, that is called the lowest standard point. Okay, my first. And 100 degrees Celsius is the boiling point of water. So it is called the upper standard point. So water freezes at 0 degrees Celsius. That is called what? See, look here. That will be called as lower standard point. All right. And this 100 degrees Celsius temperature, that is being called as?
Sir, boiling. No, sir.
No. Upper standard point. See, read this one here. What does it say?
On the thermometer, 0 degree is the melting point of ice and called the lowest standard point. 100 degree is the boiling point of water and is called the upper standard point.
Right. So these are the lower standard point and upper standard point of water. All right. So the most common of them are Celsius, Fahrenheit, and Kelvin scale. So in a clinical thermometer also you will see the Celsius scale and Fahrenheit scale, both of them are mentioned, right?
Yes.
Okay. Now let's study about each of them in detail here. See the Celsius scale. In the year 1743, there was a scientist named Anders Celsius who invented the Celsius scale. Okay. So he determined the freezing point for water to be at 0 degree, and the boiling degree he found out it was 100 degrees Celsius, right, Mafaz? And in between this 0 degrees Celsius and 100 degrees Celsius, it's obvious there are 100 divisions. All right. So that was the clinical thermometer. Who invented it? Named was the scientist?
And Celsius.
Anderson Celsius. Remember the name of the scientist. Okay. And next was the Fahrenheit scale. Okay. It was developed by Daniel Gabriel Fahrenheit. And the unit of this scale is degree Fahrenheit. Okay. In short, it is written as F. All right. So on this scale, what is the freezing point of water taken as?
32 degrees, 32 degrees Fahrenheit.
Exactly. 32 degree Fahrenheit. Okay. What about boiling point?
212 degrees Fahrenheit.
212. Okay, now another one was Kelvin scale. Another one is Kelvin scale. So it was invented by Lord Kelvin. Remember the name. Kelvin scale was invented by Lord Kelvin, and the unit of temperature on a Kelvin scale is K simply. It is K. Okay. And in this, the freezing point of water is taken as 273 Kelvin. Okay. So freezing point here is how much? 273 Kelvin. Okay, what about the boiling point?
So,
Yes, how much is the boiling point on Kelvin scale?
373.
373 Kelvin. Right. Okay, see, there's a comparison being made here in a Celsius, in a Fahrenheit, and in a Kelvin scale here. So you see, boiling point of water on a Fahrenheit scale is 212 degree. Okay, while freezing, while on a Celsius scale it is 100 degree, and in a Kelvin scale it is 373 degree. Okay, Mafaz. And see,
Yes.
the freezing point of water in a Kelvin scale is 273. On a degree scale, on a Celsius scale, it is 0 degrees Celsius. and in a Fahrenheit scale it is 32 degree, right? So you got to remember these things, that is the boiling point and or what is the boiling point and freezing point of water in different scales. Okay. Okay, now you tell me, have you done conversion of scales? Like if I am telling you that this is a given temperature in Celsius scale, convert this into Fahrenheit scale. Okay, do you know the calculations? How do you do that?
No, sir.
Okay, okay. Look, if you are provided with the temperature in, let's say, Celsius, okay, and you need to convert that temperature in Fahrenheit. Okay. Now remember the formula. I'm telling you the formula because I guess you can remember the formula also, and it will help you in your further classes also. Okay. So if you appear for Olympiad exams and competitions, this will help you in that as well. Okay. So suppose you are required to convert cells temperature given in Celsius in Fahrenheit. There's a formula here. Okay. That formula is what you know. C multiplied 9 upon 5 plus 32. Okay. So let's say I am providing you with the degree Celsius temperature. The question is convert 50 degrees Celsius in Fahrenheit. Okay. So pay attention here. Mafaz, see how we are doing this. Yes. We are required to convert 50 degrees Celsius in Fahrenheit. So you will put the value of 50 degrees Celsius here in C here. So the required formula is C multiplied 9 upon 5 plus 32. Right, Mafaz?
Yes,
So
sir.
in place of C, we are required to write 50 here. So it will be 50 multiplied 9 upon 5 plus 32. So you will cancel 50 by 5 here. Right, Mafaz? That will
Yes,
give you 10 multiplied 9, that is 90 plus 32. So what is my required answer here?
sir. 122.
122
22.
degree Fahrenheit. Okay. So this is how you convert Celsius temperature given in Celsius into Fahrenheit. Okay. Now solve one question here. Okay. Question is convert 60 degrees Celsius to Fahrenheit. Convert this in Fahrenheit. Okay, take your time and solve this one.
Ma'am, sir, 140.
140. Okay, let me check that. 60 multiplied 9 upon 5 plus 32. Very good, very good. Okay, so that is how you're required to convert Celsius temperature into Fahrenheit. Now let's do few more questions. Okay, now we are required to convert a temperature given on Fahrenheit scale into degrees Celsius. So how do we do this now? Fahrenheit to degree Celsius scale. Okay. Now, in this case, what you are going to do, it will be F minus 32, okay, multiplied 5 upon 9. Okay. This is the required formula then. Okay. So if you're provided with a temperature in Fahrenheit and question asks you to convert it into Celsius, okay, this is how you're going to do that. Okay, so let's say I have a question. Convert, let's say 200 Fahrenheit into Celsius. Okay, so you will simply put the value of Fahrenheit in the given formula, that is 200 minus 32, right, Mufas?
Yes, sir.
Okay, so that is 168 multiplied 5 upon 9. Okay, now calculate the value. What is the answer here?
Mm,
Yes, it will be in decimal.
so 93.25.
All right, 93.25 degrees Celsius. Okay, don't forget to write the degree. Okay, now solve one more question. Okay, so let's say you have 64 degree Fahrenheit. Okay, so what will be the value in Celsius scale? Convert 64 degree Fahrenheit on Celsius scale. Mafaz, you submitted the previous assignment now.
Yes, sir.
You submitted the previous assignment to me now. Previous science assignment. Yeah,
Yes, sir.
that was dated nutrition in animals. That was related to. Okay, okay, okay. Did you got the answer?
No, sir.
Okay, okay. So I'm noticing here one thing, that your answers are correct. Very good, Mafaz, in science, but you are not doing spelling mistakes. Okay, you are doing spelling mistakes. So that is not a very big issue, but I think you need to improve on that. Okay, you are doing some spelling mistakes, and I hope you will improve that. Okay,
Sir,
like,
I get the answer, sir.
yeah,
I couldn't get it.
yeah. What is the answer?
I got 840 by 9.
840 by 9. Okay, let's check that. So it is f minus 32 multiplied 5 upon 9. So it's going to be 64 minus 32 multiplied 5 upon 9. Okay, so that is how much? That is 32 multiplied 5 upon 9. Okay, look here. So 32 multiplied 5 upon 9 gives you how much? It gives you 160 upon 9. How come you're getting 840 upon 9? Mafaz? Okay, so it's going to be 160 upon 9. Now, solve it further. What is the value in decimal here? It will be 17 point something.
Yes, sir.
Okay. Yeah, what is the exact answer? 17 point.
Sir, I did not get the exact answer, sir.
Okay, okay, no issue. It will be around 17. 17.7 around. Okay, that will be the approx answer. Now moving on to next thing is, let's discuss one more thing here, then we will quickly move on to what we were discussing in previous class. Okay, now let's suppose you are provided with the temperature in Celsius. Okay, and you are required to convert that Celsius temperature in Kelvin. How do we do that? Okay, in Kelvin here, Kelvin. So what you are required to simply do that, you will write degree Celsius is equal to Kelvin. No, Kelvin, you are supposed to write, yeah, you are supposed to convert Celsius into Kelvin. Okay, so Kelvin equals to Celsius plus 273.15 degree. Okay, Mufas. So question is that you need to convert a Celsius temperature into Kelvin scale. So what you need to do that, you will simply add 273.15 to the temperature in Celsius scale. So let's say I'm saying you that question is convert boiling temperature in degrees Celsius to Fahrenheit. That is simple. So what is my answer going to be here? I know that how much is the boiling point of water in Celsius scale?
Yes, sir.
That is 100 degrees Celsius, right?
Yes, sir.
So Kelvin, it is going to be in Kelvin.
Sir, it is
At,
20,
yeah.
27,300.15.
No. You are supposed to add the value. Okay, not multiply. See, there's an addition sign here. All right, Mufaz.
Sir, 373.15.
Exactly. So that is 373.15 in Kelvin. Don't forget to write the name of the scale. So that's it. And you need to remember the formula of all the three scale conversions. Okay. Now, and also one thing, have you been taking notes of the class now?
Yes,
After
sir.
the class is over, you need to take the notes of the class. So transfer of heat we were talking about, it is basically by conduction, okay, convection, and radiation. So we were basically talking about conduction and then we jump to convection. Quickly recall what we discussed. Conduction, as you know, it is the transfer of heat from a hotter part of a colder or hotter part to a colder part of a object. Okay, why? Due to collision of particles without actual movement of the particles. So particles are continuously colliding with each other. So due to that collision, particles are able to transfer their energy from one to another without the actual movement of particles. So you see this figure here. The particles here, the particles of this metal strip just above the candle, they are not actually moving from here to here. Okay, but they are continuously colliding with each other. So due to that collision, the heat which is being gained by the part close to this candle, that is being transferred to here. Okay, to the left side. Okay, now what are some practical applications of conduction, Mafaz? Practical applications of conductions. Okay, quickly we need to quickly cover this. Okay, we have discussed these things in our previous class.
So what is practical application mean?
Yes.
What does practical application mean?
Yeah, what is practical application of conduction? Like in daily life, and where are we using this conduction of heat?
So in
Like,
pans,
yeah, in pans, in cooking pans. Okay, what else?
uh,
In making the handles of the cooking pan, making them of a insulator material, right? Okay,
yes,
so that we don't burn our hand. And clothes are made of fur. So when the clothes are made of fur, air gets trapped in between them. Okay, So air, we know that it is a bad conductor of heat. So that also prevents heat from escaping from our body and keeps our body warm. All right. So we basically saw that in the conduction, there are two types of conductors. One category is those of good conductors. See, what are the given examples in the figure? Yeah, read the names of the substances given in the figure.
Copper, aluminum, gold.
Exactly. So these are metals here. Okay, these are mainly metals here. Okay. And in the second figure, you will see these are non-metals: wood, plastic, soya, styrofoam. They are basically non-metals. So non-metals are found to be bad conductor of heat. Okay. So we basically have categorized conductors of heat as good and poor on the basis of conduction of heat, the rate of conduction in the bodies. Okay. So materials that conducts heat easily are called conductors, while those materials that do not conduct the heat easily are called insulators. So metals are usually now good conductors of heat. You will see here. As we can see, all of these are metals here. All right. And usually non-metals are bad conductor of heat. Okay. So they are insulator. All right. Okay. So here's an activity to show that air is a bad conductor of heat. Okay, now let's quickly understand this activity. What does the activity once says here? Read this one.
To show that air is a bad conductor of heat, hold an empty glass test tube and heat its closed end on flame, keeping its mouth tilted towards lower side. The air in the tube gets heated, but the heat is not felt on the finger. At the lower end of the tube, this shows that the air is a bad conductor of heat.
Okay. So the in the first figure here, you will see here that you see we are burning one end of the tube, and we have inserted our finger on the another side like this. Okay, but still we are not experiencing heat on our finger. Why? Because we know that air is a bad conductor of heat. Hence the heat, the air that is getting heated over here, it's not transferring the heat to the air surrounding our finger. Okay. So this shows that air is a bad conductor of heat. All right, Professor.
Yes,
Got
sir.
this? Now, water and glass are also bad conductor of heat. So read the second activity here. Here. Read
Water,
this one.
water and glass are bad conductors of heat. Take a glass test tube filled with water. Put a piece of wax at the bottom in the water the help of a sinker. Heat the water in the test tube towards top, keeping it in inclined position.
Inclined position.
As shown in the picture above, water starts boiling over the flame, but the wax at the bottom of the test tube remains unaffected. This shows that water and glass are bad conductors of heat.
Okay. So you see, did you got the activity? What is happening? See, here we have not taken a glass tube here. Okay, we have filled it with water. Okay, and at the bottom of the test tube, we have put in some waxes here. Okay, so here we have put some wax. Okay, at the bottom we have put in some wax material. Okay, so we have tilted this test tube. Okay, and we are heating the test tube towards the top, keeping it in an inclined position here. Okay, so what you observe here, although this water starts to boil, but the heat is not transferred to the bottom of this test tube. So this concludes that glass test tube and water is a bad conductor of heat. Right, Professor? We conclude that water and glass are bad conductor of heat. Getting it what's happening here?
Yes, sir.
Okay then. Now we were talking about convection. Okay, now you see convection is the transfer of heat by movement of particles. Okay, and that movement of particle generates a current. What do we call that current?
So
Yes, you see what happens when you are boiling your water. Look, see this figure here. Yeah, just let me zoom it out. Yeah, see this figure. What's happening here now? The molecules of the water present at the base of this bowl here, at the base of this container, they will get warmer and they will start to rise. Since warm particles tend to rise above, okay, so they will start to rise above, and again when they are back to the surface of the water, there the temperature is cooler, so they will cool down and again they will fall back to the bottom, and again they will get heat up, and this cycle keeps on going, right, Mufas? So this generates a continuous movement of water particles, water molecules in this container, and that is called as convection current, right, Mufas?
yes, sir.
Okay, now can you explain convection current to me now?
When the molecules when they heat up, they um, uh, rapidly move here and there.
Okay, look, convection current, we explain it like this. Okay, what happens in a convection current? The molecules the molecules of water close to the heat, they start to rise up, and when these molecules reach to the surface of the water, they again become cool, and they will fall back to the fall back to the bottom of the container. Okay, and this cycle continues for all the particles of the medium. Okay, so this generates a form of current that is called as convection current. And same thing will happen for air also. Okay, that same thing will happen for air also. Okay,
Yes, sir.
so in a convection current, there is a cycle of movement of particles of medium. So especially they are liquid and air from hot to cold region, right? So there's a cycle of movement of particles. See how they are moving like this. Okay, particles first they are moving above, because from bottom they are experiencing heat. They will move above. Again, when they come to the surface, they will cool down, and again they will fall back to the bottom of the medium. So there's a continuous cycle of molecules going on here. That's why it is called current here. That is convection current. All right. So now in nature, there are some phenomena which you will experience because of convection currents. So what happens in the day, the land heats up faster, you know that? Okay. So during the daytime, land heats up faster than the water body, than the sea. So the air above the land becomes warmer in comparison to air above the water. Right, Mafaz?
Yes,
So what will happen? The air above the water will start to rise upward. Okay. And the cooler air from above the sea, it will rush towards the land and takes its place. So it goes on like this. Look here. This is your first one is, see, let's say this is your land. Okay. And this is sea here. Okay. So we know that land heats up faster. Okay. So the air above the land, it will start to rise.
yes,
All
sir.
right. And the air above the sea, it will not rise up very quickly because sea heats up lately. Okay, so what will happen? The movement of air is always from higher pressure to lower pressure. So since the air above the land has started to rise up, so there will be low pressure region here. See here, it goes on like this. The molecules of air are rising above. So there will be a gap created here. So that will lead to low pressure region. All right, Mafaz. And on the seaside, there is abundant amount of water molecules. They are not quickly rising up because the temperature here is still lower. Okay, so there's a high pressure in this region. There is high pressure in this region. That is why the movement of water will be from sea to land side. Okay, so we'll basically see here the cooler air from above the sea rushes towards the land and takes its place. So this results in a sea breeze during the day. Got this, Mafaz?
Yes, sir.
Okay. And at night, we know that land cools faster. Okay, land has a characteristic property that it will heat up quickly and it will cool down also quickly. Okay, so during the night, land cools faster. Therefore, the air above the sea is warmer now. Okay, the air above the sea is now warmer because sea tends to heat up lately and also cool down very lately. Okay, so during the night time, the water above the water of the sea is still warmer. So air above the sea is also warmer. Okay, so therefore the air above the sea is warmer than the air over the land. So at night, cooler air from the land replaces the warmer air above the sea, which results in a land breeze. Okay. Now, what are some practical examples of convection in our daily life? Yes, Mafaz.
The boiling of water.
Boiling of water and
Mm,
see, room heaters are placed on the floor of a room. Okay, when the cool air is heated, it rises up and cold air flows down to the floor. This also results in a convection current in the room. Okay, and also leads to effective heating of the room. See, this is a room here. Okay, and in the corner, you are putting a room heater. All right. So the air surrounding this room heater, they will start to rise up. Okay. And the surrounding air, which is cooler, it will come close to this room heater. They will again get warmer and there will be convection current generated in the room. And hence all the particles, all the air molecule in that room, they will be heated up. Hence it will lead to room getting heated. And you see, exhaust fan in kitchens are also fitted high, right? So that they can release the warm air outside of the room. Okay, because hot air, it will speeden up the rising of the hot air. So if you are sitting in a room and if you are experiencing if you experience warmth in that room, and if you on the exhaust fan, you will see that the warm air, it will start to rise. Suppose in a kitchen you have got exhaust fans, so you will see the smoke coming out of the food. Okay, once the exhaust fan is on, they will start to rising up, this smoke coming from the kitchen. Similarly, ventilators of room are also at the top of a window or the door. Okay, why is it so? Because when the air in the room gets heated, it rises up and passes out from the ventilators at the top. Okay, Mafaz. Okay, now let's come to radiation. Now, what do you understand by radiation here?
so when the heat travels through the air.
When the heat travels through the air. Look, the heat that is coming from the sun, the heat that is coming from the sun to our cells, in between that, you have got atmosphere, layer of atmosphere, but in between the layer of atmosphere and sun, is there any medium? No, there is only vacuum there, right? So one thing we are clear about this radiation here, and another thing is that it will move in the form of rays. It will move in the form of rays. So the transfer of heat in the form of waves for which a medium is not required is called simply radiation. Okay, now these waves can move through vacuum also. All right. So that is in short about radiation. Okay. Now, what are practical applications of radiation?
Yes,
So
sir.
what are some practical applications of radiation? You see, solar heaters are designed to use the heat energy from the sun for cooking food. So you have got solar cookers.
Yes, sir.
Yes. So you have got solar cookers which you can use to cook the food. Okay. And we also prefer to wear light colored clothes in summer because light colors are poor absorbers of heat. Okay. And in during winter time, we prefer to wear dark clothes because they are good absorbers of heat, which will keep us warm. Okay. So there are two practical applications of radiation in our daily life. First one is the use of solar cookers. Second one is of preferring to wear light clothes in summer and dark clothes in summer. Why is it so? Yes, Mafaz?
Yes, sir.
Why is it so? Our preference of color choices differ in summer and winter. Like so in summer, we prefer light clothes because they are poor absorbers of heat,
So they
right?
reflect, so they reflect the uh, sun.
They reflect the sun's radiation.
Yes, sir.
Exactly. They will reflect the sun's radiation. Okay. And while in winter, if you prefer to wear dark clothes, okay, they will absorb the sun's radiation, which will be absorbed into the clothes. Okay, now see here, we often use electricity and fuels like coal and wood to keep our houses cool or warm, right? But is it possible to construct buildings in a way that are not affected much by heat and cold outside? So how it can be done? So this can be done now by constructing outer walls of buildings so that they have trapped layers of air. Okay, like this is the main wall of the building, let's say. Okay, and outside of this wall, you construct another wall outside the main wall. You're getting it what I'm saying?
Yes, sir.
So you have an extra layer outside your house so that air is trapped in between the layer. Air is trapped in between the two walls. So we know that air is a very bad conductor of heat. Okay, so that will help our houses not getting too warm during summers or not getting too cold during winters. Okay, but nowadays another way is using hollow bricks. Okay, so instead of building a false wall or another layer of wall, you can simply use hollow bricks. Okay, so it is clear now that why do we wear light colored clothes and dark colored clothes in winters. Okay, okay. So we earlier discussed this one as well. How do woolen clothes keep us warm? Okay, because we know that woolen clothes, they are what? Good conductor or bad conductor? It is supposed to be good conductor
They're bad conductor.
or bad conductor. Okay, how is it so? Because they trap in air between them, right? Suppose this is a piece of woolen fabric here. Okay, in between woolen fabric, air particles will get trapped. Okay, and air particles will get trapped. So we already know that air is a bad conductor of heat. So there is no possible way for heat to escape from our body to the outer environment. Okay, so what happens? Air present between the woolen clothes and our body becomes hot, and this makes us feel warm. Okay. And also similarly, two thin blankets will provide you more heat than just one blanket because air gets trapped between the two thin blankets. Okay. Now the chapter is complete. Okay. This is it. This is it about the chapter. Okay. Now come to the exercise part here. Okay. We have got limited time, so we will solve first three questions only. Rest is going to be assignment. See first question here. What are the similarities and differences between the laboratory thermometer and the clinical thermometer? Yes, Mufaz?
Sir,
Okay,
sir,
what do
the range is 35 degree to 42 degree including a thermometer.
exactly? One thing is about the difference in their ranges. Okay, all right. And what are the similarities? They both of them uses uses mercury. Okay, and both of them are made up of glass material. Okay, okay, and rest of the questions are going to be part of our assignment. All let me fast. See,
Yes.
all these questions. Yeah, just